What's up, guys? Had a little bit of difficulty there for a moment. Restream was misconfigured. Alright, so today we're going to be doing some live programming. Let me make sure my Twitch is working. I was going to be using my desktop this time around, but I couldn't get my editor configured correctly because there's something wrong with the settings. So I don't know what the hell happened there. So yeah. Alright. So I'm here on the Daily Prog website. This is the programming community that I'm a part of. I originally started this channel, this community rather, with a couple other people a few years ago, and it's grown pretty big. We have 57 people online right now. We have a GitLab group. We used to be on GitHub, but we had a migration to GitLab. And yeah, so if you guys are looking for some camaraderie, yeah, come join the site. We have a new website here. We had an older one. We had to replace it because we were migrating and there's some difficulty there with the existing setup. So these aren't this isn't everyone, but these are the people that have configured their pages. You can go ahead and go to dailyprog.org/chat and join me in the chat room there, or you can go on the actual IRC network. But yeah, so we're a pretty big community now. Lots of good discussion going on there. I can hardly keep up sometimes. So if you guys are interested in joining a programming community, then yeah, check us out. So I haven't worked on this project in a few weeks. Been kind of busy doing other stuff, you know, typical round of excuses. But you know, we have a lot to do. So let me just give an overview of where we're at right now. Alright, so we kind of have a lot of functionality we need to create, right? Because what we did in Grindcation, which was a 1 week long streaming binge, essentially, what we did was we basically started migrating to a new architecture. Before, TinyCDN was kind of really just a file server that worked on a single node, and basically my goal now is to create a distributed system. This turns out to be pretty complicated. So I spent a couple months re-architecting the design, and in that week I did a significant amount of code rewrite, yeah, so In the last episode, we basically got some test, or we got the code to compile, got a few tests to run, and not passing, of course. But basically, these are kind of our tasks right now. The client node actually is the only thing that doesn't compile, so maybe we can do that at some point. But I think right now we're going to focus on this hashing ID for file IDs. And yeah, so the file IDs don't actually need to be that large. I think we can get away with like 32 bits. The important part about file IDs is that there's no hash collision on the bucket itself. Now, given the buckets already have hash entropy with their IDs, let's go in the code here. Given the bucket already provides uniqueness as well as the virtual volume, the file ID just needs to be unique within the context of its bucket. So the ID doesn't need to be that big. So if we look into file, so we have file ID here. I think file ID isn't defined anywhere, so I have to make that an alias. But essentially, we'll make it 32-bit. And I think at one point I wanted to do something like MongoDB does. Now hear me out on this. Basically, what MongoDB does for its IDs is interesting. Basically, when you get a ID for a object, they prepend the MAC address from the router on the local network, and then they also add a few extra bits at the end to add some kind of uniqueness. So basically, how it works is, and I think I wrote some code on this before, actually. Set C style. Oh. Sorry, I'm just noticing it's not respecting my C style. Yeah, so it's not. Okay, so basically what it does is, so let's say we have, you know, basic kind of counter, right? Or this, you know, it doesn't have to be in this order. It can be from like a, you know, something like that, right? It doesn't really matter what bit gets set, where, right? But basically the point is, you have a small 3-bit counter to give you some level of entropy. So basically you would increment this counter. You would have a lock on the key generation factory. The key generator would basically lock when it's about to increment the bit combination, and basically it would increment this and append it to the final 3 bits of this ID. So the purpose of that is that essentially you will never get a duplicate ID from the same key store. So essentially, it you know gives a huge amount of entropy because from the same key store or same key generation thread, so that it is pretty much guaranteed that the chance of a hash ID coming from the same thread is impossible. Now, this doesn't guarantee, when you're looking at across time, but it temporally, basically, the likelihood of a hash being similar to another hash within the same few seconds, that might be more likely than across like two completely different times, and that's just due to how random number generation works, your source of entropy, etc. But basically, the file ID will basically be a random string of a certain number of characters plus these 3 bits of entropy at the end to guarantee some counting mechanism. So that way, if the first 29 bits are similar or are exactly the same, that at least the counter would be different. And I'm not a cryptography expert, but basically that's a pretty good idea. Now, what I don't know is if we want 64 for file ID but 32 for volume, because there's not going to be that many volumes compared to files. There's going to be a lot more files. Oh yeah, files have to be unique by volume. That's the thing, not only by bucket. Right? So maybe it needs to be 64-bit. Or maybe I can get away with 46. No. 44. 44-bit. Something like that. I don't know. We'll figure that out. Or not 44. What is it? 48. 48-bit. Because let's see. So file bucket IDs need to be unique across an entire virtual volume. So there's quite a bit of them. Volume IDs need to be unique across a virtual volume, and there's quite a lot of them. And then file IDs need to be unique among the volume it is present in, and also inside the file bucket it's in. So you have 2 chances of collision. Whereas you only have 1 chance of collision for file bucket ID and volume ID. So I don't know. So I'm gonna basically write a note. So what are chances of collision? But for now, we'll say this 48-bit because there's gonna be a lot of them. We're just trying to save memory, right? Because though in storage, but really for file IDs, I'm trying to think. Basically, most of the overhead comes from the actual files themselves, and the files aren't really kept in memory. the file IDs aren't really kept in memory. At least if they're not cached, right? Okay, so okay, so we commented on a lot of stuff here. So I'm gonna try to compile so let's just see. I think that's the only error that we had. Alright, yeah, so we don't have the linking fails because we don't have quite a bit of methods defined. So what I'm going to do is I'm going to kind of cheat here. All of these undefined references, I'm going to basically create the equivalent method. So I think I left a lot of them unimplemented because that's how I know to fill them in with code. But we do want it to compile. So file, so load config and file. Load config. So we don't have that here. We have load registry. So yeah, that's different. That's the storage cluster session. Oh, that's file test. Oh, I didn't realize. So that's different file. Okay. So storage cluster session. So let's do this one at a time. So let's go into the test for file. And we're basically we're gonna try to see what we can kind of get working in the test. So undefined reference to storage cluster session load config. So load config, that's here. So it gets pretty much to about here, and then it fails right here, and also spawn. So we're going to go into storage cluster, and we'll at least populate the method. So let's see, so storage cluster, open it here in Qt Creator. Okay, so what we're gonna do, we're gonna say we need this in the file, so add definition in storage cluster CPP. And we can just get rid of these extraneous headers here. And I'm just being lazy, but this is very efficient. Okay. Okay. There we go. So now if we see, like, we can recompile, and we'll see that configure storage cluster node is not there, but in spawn, I thought we added spawn. Yeah, we have it here. Storage cluster session spawn. So here, yeah, it's here, and then, but it's not here. So that's very strange. Very interesting. So storage cluster, TinyCDN middleware, storage cluster, okay. Yeah, I can tell most of these were generated in the same way because they're all they're not Egyptian style. With the brackets. Hello. See, this pisses me off. This battery indicator, it shows me this shit. These, like, it shows me these notifications, and it's not discharging. Like, it's plugged in. The fucking, it's something to do with, it gets to 100%, and then it, like, doesn't charge for, like, maybe a minute or something, and then it goes back to charging. Stupid. Because it doesn't want to overcharge the battery, you know. Right, so spawn, why is it spawn? Storage cluster session spawn. Undefined reference to storage cluster session load config. And we added load config here as well. So, oh, I think if we look in the CMake lists, we should see that it is not added. Right, so we don't have that there. So if we add the storage cluster, now actually this won't compile too because the return types aren't correct. So let's make this compile. To the bare minimum. So here we have storage file hosting service. We need to find out how we can create that. So we see that here. Get hosting service, get uploading service, and those are defined here. Storage file uploading service, storage file hosting service. Now they don't actually do anything. Basically, you know, not functional. Set style. Okay, so we're gonna return standard make unique, and we want to include storage cluster. And yeah, we want to return standard make unique of the storage cluster request. the same for response. Or actually, wait a minute. That's the hosting service. I think. Storage file uploading service. And hosting service. So this should go after. Okay, so that will make those compile. Obviously it doesn't do anything, but yeah, so also this shouldn't create a new one, right? The storage cluster has a pointer to it, I think. So if we go right, so we have this here. Basically, we need to do a lock. So we need to do upload, hosting service service mutex and lock. And then we don't want to return make unique. We're basically going to return the hosting service. So we're going to do standard move, standard move, and then the hosting service. Okay. So yeah, we don't create the new pointer here, though what we do want to do is in the constructor for storage cluster node, we do want to create those. And we'll actually do that in the configure procedure. Load config here. We basically, our load config just returns the storage cluster parameters. Spawn will load the config and create the object. Now, in C++, you have something called RAII. Basically, it stands for resource allocation is initialization. Now, what that means is that basically whenever you have a storage cluster an object that you essentially initialize it when you allocate the memory for it. And the reason you do this is because that way you never have to allocate memory without, you don't have to pre-allocate, you just have to allocate when necessary. And it's a good pattern because, you know, with constructors and destructors, you can effectively manage memory. So what we're going to do is in the constructor for storage cluster node, we're going to create the uploading service and hosting service based on the configuration. So now what I was thinking before is we have this configure method, but I don't know if that's necessary because you're going to want to create the storage cluster node and immediately create the hosting service and uploading service, because you're not going to want to like have a storage cluster node that does not have an uploading service or hosting service. That would be useless. So instead of that, we're going to say no thanks, RAI. And basically, we're going to take the params here and then just pass them into the hosting service and stuff. So all the params like ID, name, location, those can just go kind of in the constructor. So we want to say UID for ID standard string name. This is annoying. Standard string name and fs path location. And we're basically going to do some static we're going to do some initializer syntax stuff where we take we want to say ID. Does that keep happening? ID, ID, name, location. And this will just we'll just initialize those straight away, and then fuck it, we'll do it in line. And then we want to say actually we don't want to do that in line. Okay, so we want to move the constructor. So just go. Yes. Okay. So we want to basically so we basically we want to create them here. So we're gonna assign the oh shit, I fucked up. Okay. I overrid some changes here. Cancel. Let's copy that. I'm using two editors here because it's easier to generate in Qt Creator than not. Okay, so right, so we want to create the storage cluster node. Basically, what we do need to do is we need to assign the virtual volume, right? Because the virtual volume is pretty much the most important part. Yeah, so we need the virtual volume config as well. I'm gonna not mention that, but we're gonna say basically we'll put a to-do in the constructor. To-do, this has to either create a virtual volume or create a new virtual volume or parse a file pertaining to an existing virtual volume. So basically, the storage cluster node, hello, I'm working on a distributed content delivery network, sort of like Cloudflare, Amazon, etc. Um, okay. So the storage cluster node owns virtual volume. Basically, the storage cluster node operates as the main process on a storage cluster process. So in TinyCDN, there are three primary nodes, right? You have a client node, storage node, and a master node. Now, a master node is basically your high availability facilitator of transactions on the storage clusters. So the master is primarily concerned with high bandwidth, forwarding requests and responses from the client to the storage cluster. The storage cluster is right now comprised of a single storage node, which has a mechanism of storage, and it hosts what's called a virtual volume, which is an abstraction of a gigantic file store that comprises of many different volumes inside of it. Now, the storage cluster node is essentially this host of the virtual volume. Now, in the future, we may have a different type of volume server, which hosts volumes within the storage node. But right now, we are not doing that because this is the first step of making it decentralized, and then distributed, and then we'll go the second mile once this works. So each node has its own variant of the kind of like uploading session, hosting session, uploading service, etc. So what is this editor? So this is GNU Emacs. So you guessed correctly, and I'm not running Windows XP. I'm running Ubuntu Mate, and so I'm running Ubuntu Mate, which has a Windows XP theme. So I'm using that. Right. So yeah, that's our architecture. I'll probably put this in the repository. I might hire someone to do code review, because I'm really curious what a professional C++ developer would think, because I am not a professional C++ developer. I'm mainly a web developer, JavaScript, Python, but I've been programming for over 10 years, so whatever. Anyway, cool. So we have those two methods. These should work. You should compile. Alright, so this has to either create a new virtual volume or parse a file pertaining to an existing virtual volume and create that volume. So the virtual volume is a meaty class. It's got a lot of different responsibilities. So yeah. So what we're going to do, we're going to say uploading service is standard make unique of storage file uploading service. And this will need kind of multiple parameters right now, but since we don't have that implemented, we're just gonna put that there. Same thing for hosting service. Motherfucker. No, this isn't old. It's not old at all. It just gives you that impression intentionally. I'm not a light theme guy on EMAT. I like coding. Programming. I use dark themes usually, but I've started digging this like Windows 95 aesthetic. You know, vaporwave. So, yeah. Alright, so storage cluster receive master command. This is kind of a really important method. We're using what's called the command pattern. Basically, a master node will send a TCP packet to the storage cluster, authorizing a storage transaction. Given that token from the user end, the user will be able to upload to the cluster. Now, this obviously won't be directly to the storage node itself, meaning the user does not have knowledge of the internal network of the cluster. It is basically forwarded from the master to the storage node. And this is why the master is very high bandwidth, high throughput, because it has to forward all uploads. So you have double the bandwidth that you're actually consuming, so to say. So you have the bandwidth of the user communicating with the master, and then you have the bandwidth communicating from the master to the storage cluster. So you have 2N effectively. So the cost to upload content is twice the file, in terms of network cost, is twice the amount of the length of a file. So if the file is a megabyte, you're going to take up 2 megabytes of bandwidth. 1 megabyte on the internal network of the CDN, and 1 megabyte from the user. So, and of course the internal network will be much faster than the external facing network. So you'll be able to do them in tandem. So the chunked cursor will effectively be able to the chunked cursor is the data structure we have. In utility here, basically we'll be able to chunk parts of the buffer and upload very gradually, each time a chunk gets uploaded from the user, we will be able to very easily send that to the storage cluster as the user is uploading. So, or maybe after the entire transaction. I don't know if we'll want to do that in parallel or not, or concurrently rather. Anyway, getting off on a tangent there. So, receive master commands. We're using the command pattern, which is from the Gang of Four book. So it takes the storage cluster request and returns a storage cluster response. So we're going to go into response, and we don't have anything here. It's kind of a wasteland here. So we'll just use this incomplete struct. We're gonna say, or class, we're gonna say does the request have anything? Okay, so we don't have anything there. So we're gonna take that and we're gonna parse it. So we have to say to do parse request, and basically we want to say to do handle response, and this will be overloaded for each command. So like basically what I could do is I could have a virtual function on storage request, and you can inherit from storage request, storage cluster request, to handle a different request differently. What I would rather do is I would rather have a receive function for each different type of request. So in effect, we'll have a visitor pattern. We will use a variant. So there will be different variants of the types of requests. So we'll have some type of the different types of storage cluster requests that are possible, etc. So we're gonna say here in receive master command. So rather than the command pattern, yeah, we don't want to do that. Well, we want to do a very similar thing, but basically we don't want any virtuals because virtuals are bad. Yada yada yada. Normally I wouldn't be opposed to it, but since we'll be doing these kind of requests consistently, then the overhead of calling the virtual table functions will be significant, because our goal for some of these functions is to be able to run them thousands of times per second, and this is one of those functions. So that's why I don't want to do that for this particular method. Normally, like for instance, storage. File storage, right? Storage has virtual functions. Now, this is kind of not as bad, because here our bound is not really how many function calls we can do a second, because all of these functions are IO bound, meaning that the cost of looking up the virtual table function for the particular subclass is very small in comparison with the operation that is actually occurring. Whereas here, our bound is how many network requests we can get. So we are communicating, or basically it's how many requests per second we can parse and retain in memory. So our throughput is highly dependent on how many requests we can parse. and suspend those requests, or at least put a response, so that way we can get something back to the user, or in this case, the master node, or whatever. The master, so actually, the reason why I had this is receive master command is because master commands are different types. Then, oh, never mind. Source cluster doesn't communicate with the client node. Oh, it does actually. I think it does. So anyway, we're gonna be doing, we're gonna use variant for different types of commands rather than virtual class. And this will just make it easier to get high throughput. So our bound is networking, which will be really fast. So it'll be, on a storage disk, even with the fastest PCI 4 SSDs, you're talking about 5,000 megabit read. With internet, if you're on a gigabit line, you're not really bound by your network. So yeah, so hopefully that makes sense to you guys. Okay, the client does not need TCP wrappers. That's right. So that's why we don't have the receive and send client command, because the client in this case is a C function, C program. Okay, so parse request and a response. We're just going to return a new storage cluster response. And we're not going to do anything there. Send master command. So this actually basically does a TCP. It sends a TCP. It sends a TCP packet from the storage cluster notice to the master. So send master command. So we're gonna say so send a TCP packet. Inquiries. Send a TCP packet to the master. And I'm trying to I want to try to comment as much code as I can while I am rediscovering this, because if I pay somebody to code review it, then it would help them. I'm thinking about doing that because I really want to get the code structure and the right things in place, so when all the functionality gets implemented, that the kind of structure is sound and the kind of expandability, maintainability, all that stuff, all that good stuff, that it all works out. So what do we got in the chat? Inquirious. Very inquirious. Alright, so, okay. So send master command will basically send TCP request to TCP packet to master, pull for master response to do. What if master goes down? So that's like a very fucking important thing, right? So if any of you have used Elasticsearch, it is a search system, distributed search query system, and the way it does master nodes is it elects a master, right? So instead of having a separate master node, the master is elected from the various different nodes. Now, I was thinking that this might be a good idea for TinyCDN, but then the problem is let's say you have content on a storage node, and a storage node has high CPU usage. CPU usage spikes because there's a lot of content on there that is being requested. Now, would the master become re-elected because of that? Would it become, you know, how would you deal with that? Like at runtime, how would you change the master so that it's not noticeable? I'd have to investigate how they do that. And the other thing is, at least in terms of Elasticsearch, how its sharding works is each shard is basically part of the same cluster, right? So whereas in this case, for the master, we basically said that the shards are part of the virtual volume, and they kind of exist within their own way through the volumes. So the volume is basically a shard of storage, but each virtual volume is configured in a different way. Each virtual volume is basically unknown to most of the storage clusters, because the storage cluster node is only concerned with a single virtual volume. So if the master has to be aware of many different storage clusters or many different virtual volumes and their relations, etc., it makes sense to have a dedicated master node. That's what I'm thinking. But I'm still open to that idea of maybe, you know, of having non-dedicated master node and rather having an election. It does complicate things. It does complicate things because of the fact that the virtual volume is unknown. The mapping of virtual volumes. Okay, so and there's poll for master response. When master response is acknowledged. Okay. So maybe instead of void, we want a response like this is like a future acknowledgement response or something. Let's go ahead. Let's do. So acknowledgement response, what I mean by that is just a generic like acknowledgement that the response that the request was received and that it's being parsed in some way. So it's possible should acknowledgement response have an ID. So basically it's possible that in the acknowledgement of a request that we'll want to continue that later on. We'll want to basically acknowledge the request happened and basically tell it, hey, wait for this token ID or this ID to pop up. Once this ID pops up, then you can continue the process, the next image, the next what's my train of thought? Yeah, anyway, you'll be able to continue the event loop based on the ID. Maybe, I don't know. So, or stateless. Probably stateless. Because with stateless, we basically just have to blindly trust the master. The master is like, okay, I'll acknowledge it. Later on, you'll be able to handle this in some way, some fashion. And there's no state. I think that's okay. So, I think that'll work. So, okay, so we're on low viewership right now. I'm a bit disappointed. I'll probably hit this stream all day because I feel like most people watch at like Saturday night, basically. And yeah, so Thank you. Yeah, I like it too. You know, I used to be a fan of these tiling window managers, you know, and basically my issue with tiling window managers isn't so much the tiling. The tiling is great, obviously, but it's this fanatical minimalism, this toxic mentality that the less packages you have, the better your setup is. And this is toxic because it encourages collecting groups of packages together, collecting software together that does not communicate well with each other at all. So the whole point of desktop environments like GNOME, KDE, etc. is that every program, generally speaking, can communicate with each other through dbus, through some sort of standardized I/O, and the Unix people or the tiling window management people are like, no, we're going to go back to the Unix way with a single file, communicate through the file. And it's like, that doesn't work, you know? Like, setting up Wi-Fi has 10 different ways to do it. There's 10 different ways to do it in all these distributions. And there's like a million ways to do anything. I mean, there's problems with desktop environments too. Like, how many lines of code do you think having this indicator applet thing took? Like this little Bluetooth indicator. How many lines of code do you think this is? It's got to be, I mean, just for the indicator itself, it's probably like 1,000. Bare minimum. There's no way. This might even be XML. You know, it's just shitty. It's so shitty. So, but I'm willing to deal with that because I just don't have enough time to configure the minimalist, like, tiling window manager bullshit. And I've had a few configs over the years, and they've done pretty well, but like for me, but I just felt like too many problems, too much bullshit. And even with Mate, I'm getting bullshit. Like, I like my setup, but I'm getting fucking tearing in 2019, you know. And Wayland is a disaster too. Like, Wayland, kidding me, has like less than half the features of X. OBS doesn't work. Each desktop environment has to have their own copy paste. It's just a disaster. That's my mini rant on GNU Linux. Anyway, so yeah, send master command, send TCP packets master, pull for master response. When master response is acknowledged, okay, to do. What if master goes down? Timeout. Okay, so storage cluster session load config. Basically, it's gonna take this file. So take file. And this, so Marshall config into storage cluster params, and then return params. So basically, when we load config, it's going to load the parameters into memory. And after loading it into memory, as soon as the spawn procedure is called, then we can begin the master cluster node spawn. So I think... So we had start session. Interesting. That's interesting. Wait a second. So we have start session, but what's spawn then? If we have start session. Start session. Oh, right. So we wait for the initialization packet for master. Storage cluster node JSON marshaller, parse the config. That's where it is, right? Now, start session. So I believe our idea was to have all the networking code in the session, and the node would just do operations. So in that case, send master command would be in the session, not the node. So the session would send the master command, or maybe it would be the storage cluster node would take the session as an argument. So we take a request and the session. So I think that would work, because then it's still, oh shit, actually. So I wanted this strict separation of the two, right? But I do want the, so receive, send. So I think receive and send should be on the session. Right, so we have, oh, it is in session. That is in session. That is in session. Okay, so it was that way. I just messed up here. That's right. So it was here. I'm just an idiot. Right. So we don't need to worry about that. Take file, marshal config, and load storage cluster event. Okay, so load config, we'll parse that. Start session. I feel like spawn is the same thing. So I'm gonna move this because there's no reason. So spawn config location, config file location is in load config. So basically config file location will already exist. We already parsed the file. So we already parsed the file, and then we want to marshal it. So that's over here. Okay, so and we really want this marshaller stuff to abstract this away. This kind of like loading a file, throwing a logic error if it whatever, you know, fails, etc. We really want that to be abstracted away by the marshaller. The marshaller should just be able to take a file from JSON and give us a param pack. We should just return, so let's return any storage cluster params. And you know, we'll see what happens. So Okay, so 2D networking. So we'll do this here. So something like here. This is kind of our mocked code here, where we take a marshaled, or it should just marshaller should just directly, yeah, return us to object. I mean, we could do that. But you know, the problem is that basically we would have, yeah, no. Okay. So it'd create us a storage cluster node, but we'd have no networking, right? So we wouldn't have any networking. So remember, the node doesn't do any of the networking. The session does the networking on behalf of the node. Okay. Wait forever for initialization packet. Then once we do that, so I don't know if we really need to return store cluster params or if we want to marshal. Figure this out. To do returns params or returns cluster node. I'm not really sure. So wait forever for initialization packet from master and networking send acknowledgement packet to master, initialize. So basically we would initialize TCP server, wait forever for initialization packet from master, it's an acknowledgement package, master, initialize network, or initialize server to do networking. And then send master success or failure. Ready to parse. And to do networking final master acknowledgement packet. Receive final master acknowledgement packet. So this is our process. We have a basically all of these steps, these 6 steps. We initialize the TCP server. We wait for the initialization packet from the master. We send the acknowledgement packet to the master once we've received the initialization packet, so the master knows we've received the packet. That way the master also knows our ping effectively, and we can judge the health of our cluster, starting our cluster that way. Then we initialize the networking server. We send the master the success or failure response from starting the server. And then we receive the final master acknowledgement packet. So that's 6 steps. Once we receive the final master acknowledgement packet, that's when the process is ready. Any storage cluster request is basically allowed through. So basically, until we reach this final point, we cannot. Until this point is reached, no storage cluster request is allowed. And this is so basically we can kind of guarantee that our server is healthy, our cluster node is ready. So there we go. This should compile now. This should. Let's go ahead. Let's see what happens. Oh, I need to remake my CMake here. Oh no, I don't. Okay, storage cluster, uploading service mutex. Upload service, host service. So it should be uploading service mutex. Okay, what else do we have? Incomplete result type. Right. So here we want to have a complete type. So we'll just include that. So that way we can have a complete type. So storage cluster request variable incomplete type for declaration, all declaration of complete type for declaration of variable. Master request also has a incomplete type. So let's go into master. And let's look. So we have yeah, so this is where we started to do some crazier stuff. Storage cluster we don't include, so we can effectively include master. Okay, so cool. All right, so we can just include master, and master has the master request, master response thing. Yeah, so we see that we started to do this command pattern type thing here. Basically we would just overload parse, but like I said, I think we want to do it in a variant because then we can statically visit the correct parsing function. And that way, yeah, we don't need to basically have any virtual voids. So yeah, and that's important. Okay, so let's try to recompile. expected after class, storage cluster request. Incomplete result type storage cluster response. I thought I had a complete type. Storage cluster request, storage cluster response. Storage cluster response. Oh, I need that to be in the namespace. No viable conversion. Right, so that's a pointer. So I think if we just yes. Master request. Yeah. Alright, so master request incomplete type. So let's go to so actually wait a sec. So master request. Okay. Right, so this is in the master namespace. So we want to do, we want to use the same namespace. So using namespace, TinyCDN, middleware master. We're going to want to use that. So variable has incomplete type still, even though we're using that namespace. Interesting. Middleware master. If we use that namespace, we should be able to use master request. Master request. That's here. So what's the issue? Oh, it's an incomplete type completely. What? Oh, what? Incomplete type. Then I included it. I think it's because there's some collusion here. So I'm gonna say, yeah, master. Did not match any definition. Okay. Master request. Let's say class. autocomplete type master request, even though we use master. So I'm going to say this way. Unknown type name master request. So I'm going to do this instead of that. I'm going to put it up here. Oop. Definition, semester command. What does that do? No member. Right, we don't have that namespace. So, is it possible to forward declare namespace? I think so. Okay, that works now. Okay. So yeah, cool. We have the storage cluster C++ file compiling. We've resolved quite a lot of linking errors. But now we have one left. So this is inside virtual volume. Let's try to see what we can do about that. Oops. Alright, so this is the volume file. So set size. Right. Now set size is not implemented. Okay, so let's go into volume and we'll create that here. So we need to link this as well. Right, so let's see. So we have volume. And this here if it's in line. Create storage volume. Return to volume storage volume of type T. Unique pointer. So we're just gonna C style. Okay, so we want to first, this needs to include volume. Create storage volume. We'll need to so we'll take maybe any storage volume. Sorry, any storage volume. Unique pointer of storage volume. So we don't need that. Storage volume manager. Volume. File bucket volume and it returns that vector. Okay. I just want to return yeah, the FB vol. Why is it not complete? I think it's because this isn't in the compile commands. So what we'll want to do, we're going to add it to the CMake lists file and rebuild the compile commands. So that way we can get it as part of our project. So storage cluster and volume. Right, so now let's try to make, we'll get an error too, of course. We're gonna so now we have volume CPP. So now we're gonna revert buffer. That's weird. Okay. CDB auto setup, please. FB. That's weird. It should be giving us the correct thing. See? Actually, that's not correct. Whatever. So we're going to take fbvoldb, which is our map of the file bucket ID. I don't know why it's not working correctly. I'm going to kill that buffer. Let's see, irony. cdbjson select. What the fuck? What the fuck? That's not right. Okay, that's fucked. God damn it. Just be awesome. So fbvoldb get ID. That will give us the vector. Yo, what's up? So we got yeah, this will return that, and then we want to yeah, so each storage volume has like the same constructor. We only really need to use the variant or the sum type, as they say. We only really need to do that when we are visiting. So there's no example of that here. Yeah, we only need to do that if we're doing an operation besides construction. So we're going to return we might actually need to do that at some point because the storage initialization might be different for the different storage mechanisms. So like we might want this create storage volume to like take the type and do different things based on the type, but for now it'll just be a template that returns the unique pointer of that type. Then we use just a location here. Yeah, the next Haskell, yeah. Though unfortunately variants aren't they're not as performant as REST sum types, if I recall. There's like one extra move instruction or something. Or not move, something. Besides just like a 1 bit. I think it's like 1 extra bit or something. In terms of memory. So we take the location. Let's get storage. So create storage. So what do we need? We need an ID, a size. Okay. Location and pre-allocate. Okay, so size is static. So so storage volume manager has a standard size for its volume. So what is it? Default. Oh, we don't have that here. Weird. So we wanted to have it so that that there's a default size that gets constructed for each volume. So we're gonna have that as a private. We're gonna say event max t default volume size. And basically this will get initialized and each time it creates a volume it'll create it of that standard size. Size here is just the size of the cluster, size of the virtual volume. But then default volume size is a different thing altogether. That's different. So like for instance, each volume by default is like 32 gigs. So the storage volume manager will create a new volume of 32 gigs when it's instructed to create one, at least by default. I don't know if this default volume size needs to be private, because really all that would do is influence newly created volumes. And who would do that? Like, well, hypothetically, yeah, anyone can do that because it's a public storage volume manager is public. So yeah, we'll keep that as private, but we do want sometimes to access it, I guess. I don't know. Maybe not. We'll do that at construction. God damn it, I need to fix my shit. I could have sworn I had that already there. Pattern matching. Well, you wouldn't really use case or switch in C++ anyway. Like on an enum or something, you wouldn't do that. So I don't play music anymore because it's really a pain in the ass to like appeal any muting or something or anything like that. It's kind of a pain in the ass. Basically, like, I should be able to just claim everything as fair use, but YouTube only lets you appeal one song at a time. And on top of that, you'll get notifications for songs that were played on like an episode I made like 6 months ago. So if I get an alert that a song was played and I want to appeal it, I have to appeal a song about, or appeal it like for an episode that was released like 6 months ago, right? It's really dumb because they basically have this like huge asynchronous GPU cluster that does all of this fucking, you know, sound identification and all that shit. So I can't appeal them all at once. I can't just say like for the video, oh, it's fair use, because I'm not making any money or anything. It's like, no, I gotta do that for every song. So it's really dumb. Default volume size, yes. Macros, not in C++. And I don't do much Lisp these days. I should though. Okay, so default volume size. So basically when we create a storage volume, we take, we have to we also have to say if it's pre-allocated or not. So here's the confusion, right? So the storage volume will want to create the storage volumes that exist on the virtual volume, but there's a difference between creating a new one and creating an existing one. So we have this method called commit storage volume, and this commit storage volume will actually persist it into the volume DB. Now the question is, how do we use the storage volume manager only to create new volumes, as in does the persistence of the existing volumes call this method, or does it does the virtual volume create its own or persistent volume? So if it's just overloading this one, then we could have it as a bool as well. But if it is a bool, then we can just say pre-allocated is false for now. So bool pre-allocated is false. Something like that. Yeah, so that way, we can use it to create either. But when we I'm trying to look for an example. Never mind. So we just need the location. Well, that's the thing though, is if there is no ID, then we need to generate an ID, right? So where do we get the ID? So right, yeah, so the storage volume manager would have to create a new ID. So I feel like those would be two completely different methods, to create a storage volume and load storage volume. There we go. That's a better idea. That's a better idea. Make them separate. So load storage volume, I would take all of the same parameters, except pre-allocated, because we know it's pre-allocated. I like that better. Yeah, this isn't a compiler, interpreter, or anything. Plus macros and C++ are completely different. I mean, I use macros in my tests. I didn't write the macros, but you can see them in the tests, right? This is a macro. Scenario given, when, then. These are all macros. But I don't see a need for it myself. NIM is great. It's like all the benefits of, you know, Rust without the cognitive overhead. Well, memory safety is a bit worse, but it's worth it. It's worth it. Well, you know, everything being an expression is it leads to some weird kind of possible code. You can format things very strangely. In an imperative language, it makes more sense to have separate statements from expressions. Separate those two. In an imperative language, procedural language. I mean, but anyway. So make unique a storage volume for. So this would be pre-allocated, and we need to get some random ID. So I wanted to do some kind of key store, some way to generate IDs very easily, but yes, it does. That's what I'm saying. It makes sense. Because not O code needs to be an expression. Okay, so load storage volume, we'll just create a new one from false. This is true, so that's pre-allocated, and then this is false. So ID, we're gonna say auto const ID equals, oh, we don't want const. So I wrote my own little hashing thing. This is some fucking hilarious code right here. I was just like, you know, this is brute force. Works, just works, TM. This is actually, you know, it's not great. I mean, the reason I didn't want to do some bit shifting shit is, you know, anyway. So here we go. We have a UUID4 factory. This is how we generate UUIDs. But I want to do a I think I'll do a new factory here just so I can have something. So I'm gonna call it ID factory. And this will just return me a new ID. So, okay, so ID. How did I do this before? Int fixed size. Okay. And then, yeah, want that, and then want to do. The syntax is kind of weird for this stuff because I'm like overloading some operators and stuff. Basically, I created this function to generate a random C string. And then, because at first I wanted to use C strings, but then I started using, instead of a C string, ID internally creates a bit set of a string. So I didn't want to rewrite the random number generation to use standard strings, so I basically just convert it manually. So I create a string of the C string, and then I just assign the ID. So you have an assignment to a standard string of val, and so basically this will just convert the random hex string into binary, so that way we have low memory usage for our IDs. So okay, and then so the way we'll use this, we will in volume we'll just have a ID factory here, and basically what I want to do is eventually I'll have a 3-bit counter like MongoDB does, where there's a lock for generating an ID, so that subsequent hashes will never be the same, and that improves entropy supposedly. So I would do that for every single one. I don't know, like, if it's necessary, if it's completely necessary. I think that might just be because of MongoDB, the 128-bit ID that they generate, most of it is taken by the MAC address. So, or not most of it, but a lot of the potential entropy there is kind of taken away. But I have to think about that more. So ID is going to be ID factory. And we just put in that, and that should work. So that will generate volume ID. And then we need the size, right? So size in this case would be the default volume size. And instead of doing that, I'm just going to put it in line here. Make it all nice and cozy. Right. So basically how the flow works for creating new volume is the virtual volume will create the storage volume using the storage volume manager. Once the storage volume manager creates the storage volume is committed to the virtual volume. So it's those two steps, and then it is persisted into the virtual volume. Okay, so load storage volume is the same thing, except we already have the information and it's pre-allocated, so that's good. Remove volume. Yeah, so this was kind of complicated here. Remove volume. Remove storage volume. Oh, so we rename that here. Oh, so that's in line already, so that's fine. Volumes erase. Yeah, erase the volume and the mutex. Now we just have set size for virtual volume, I guess. But we need that for storage volume manager as well. So for now, let's see. So it checks if size is going down. If so, we'll replicate elsewhere. That's an issue, actually. But we'll just put this in line. Same with virtual volume. We don't really need to worry about that. So modifies the storage volume manager size as well. So we want to do set size to size, and then we want to set our own size to size. Okay, so we don't need that there. Well, design patterns kind of encapsulate design patterns give you a metaphor that's more relatable, right? Because if you look at you know higher order functions and higher order if you've ever used higher order components and React, things like that, the issue is that sometimes it's hard to reason about, like, when various nestings of closures and things like that, and having a common metaphor and common mechanism for how an object works is extremely helpful when you're trying to reason about design choices. So that's why I think using patterns is still a good idea, but not necessarily to the extent that using the original implementation is a good idea. Like, for instance, the command pattern calls for virtual functions, or virtuals, right, in C++ at least. Now, when I say command pattern, I might not necessarily mean, the original described gang of 4 pattern, but it's a relatable kind of metaphor. So it really gets across what exactly you're referring to. In this case, when we look at this here, it's referring to this kind of serialization of request into a command that the master understands, and so there's this kind of equivalency of types in the command on both nodes. So hypothetically, the conversion from the TCP packet to the command and the command back into the TCP packet should be exactly the same. So having that common type really helps. And you could think of a million ways to describe it, but essentially, command pattern is a good way to put it into view, right? And also, and this is the easiest defense of any sort of notion of object or anything. When you are referring to a process, and you can have a single name for a complicated abstraction, then you don't have, you can suppress details at the advantage of being able to have brevity, so for instance, the constructor of a virtual volume is potentially going to be very complicated. The notion of a virtual volume is also very abstract, but by reasoning about it in terms of an object, I can more easily ascertain the structure of the data. And yeah, that's kind of my reasoning behind that. Let's see. So let's compile. I think. Let's see. Do we have anything missing? So destroy. Load DB. Load DB. Load DB. Just gonna copy this. This will be kind of complicated. We're basically, we need to serialize to do load a file parse into default DP map. So yeah, that's there. And so we basically, we're kind of implementing our own little key value store here, where we just store the file bucket ID mapped to the vector of volume IDs. You know, hypothetically, this could be in any key value store. Now, it's going to be a static file, you know, and that's actually not so bad. We're only going to be looking at, let's say, 1 million file buckets per virtual volume. So the time it takes, and that's all going to be in memory, right? That's you know, that's not so complicated to load a file of 1 million entries, load them into memory. That's easy. So, you know, if we were not leaving everything in memory, you know, maybe we could use a different key value store. But in this case, since we're going to be loading everything in memory, so yeah, so at some point we want to expire entries, you know, we want to give, you know, lower cache precedence, things like that. But until we get to, you know, 1 million keys, that's not going to be a problem. So, yes, that is the deal. Objects are just structs plus function pointers. Well, they're a metaphor, right? I mean, they're a way of organizing code by nouns, not by verbs, right? If I have like take a node, for instance, right? The notion of a node. Basically, you are taking memory and you have procedures that are integral to how that memory operates. The context of that memory being in some other structure is important for that particular node. The problem with, you know, weaker typed languages is not being able to control what happens to that memory. For instance, if you are able to create a non-initialized storage volume that wasn't connected to the cluster, you would effectively allocate 32 gigabytes of memory or 32 gigabytes of storage for an uninitialized object. Now, the reason you would want to control how that object is allocated is you would want to make sure certain things happen before that constructor is called. So for that you need state, or you need a lot of, you know, state management. A lot of problems with state, exist, but it's very useful. It'd be very difficult for me to reason about certain things without thinking about them in terms of nodes, and that being the case, it has to be organized that way. I mean, procedures themselves will give you an idea of what's happening, right? You have a function that takes A and B, and you expect a result of a certain type. But the procedure itself doesn't give you enough information. And the types that the procedure takes does not give you enough information. And you can have self-documenting functions and stuff like that. You can have documentation. But unless you have, like in a distributed system, for instance, unless you have a difference between different nodes, and this is assuming a heterogeneous, computing structure, unless you have a different noun to describe what each node is, it's very difficult to reason about what process is happening at which node. At least that's kind of my view. If I had no notion of a virtual volume besides a type, I'd be able to do it, but sometimes I think having a member method, or having this kind of notion of a RAII and all this stuff, that really helps to reason about the process. And I think it's very natural for humans to do stuff, or people. I don't like saying humans like that. It's so weird. I think it's natural for people to say, this person does this something, or this thing does this, right? Like in my documentation, I say the storage node hosts volumes which host buckets. Now, intuitively, you can already kind of grasp what the storage node does. If not what the storage node does, you're able to think about the procedures that might underlie the storage node. However, if I was to tell you what the storage system was without giving you a noun, it's very difficult to reason about what happens. You would have to describe the entire process, from client to storage. If I can tell you there's three distinct data structures that each have their own specific procedures: storage, master, and client. The whole context is very, very important. Yeah, I haven't shaved for like a while, for like a couple months. Actually, a few months. No, a couple months. Only a couple months. I have a fear that when I go to OC for Thanksgiving, that my family will make me shave for a photo or something. But I don't intend on keeping it forever, to be honest. Okay, I need some water. And you find in stateless systems, sometimes it's very difficult to understand what's going on. Like HTTP, for instance. Without the notion of request and response, it would be very difficult to discern where in the process you are, right? And that's why in every HTTP framework you'll see them as different types. And typically you'll have different operations on those types. So trying to explain how an HTTP process works without referring to some notion of this is the request object, this is the response object, it's very difficult to accomplish. And so that's typically why you see that combination. So what do we got? LoadDB. Add file bucket volume. Okay. Adds volume to file bucket volume DB and asynchronously persists the mapping to disk. Okay, so we're basically going to do fbvoldb set, and we're going to set, so we need to set a new vector, because this is not a pointer to a vector. Remember, this can be infinitely copied. The problem is, right, we might have some copy of the vector somewhere, and we want to add a new volume, add a new volume to the file bucket. And we might have a process somewhere that's directly mutating that somewhere else, and we'll need a lock. That I mean, that makes sense, right? So so we got volume mutexes. I think we need bucket mutexes, right? But now the issue is, you might have many different uploads, hosts, etc. happening at one time. You might have an upload that's happening during this process. Now, let me think. What would adding a volume here disrupt? Lookup. I think we're fine, actually, because if we don't need a lock, because I think if volume is if it's adding a new volume, basically by that point the request, so let's say we're running on storage, we're at like 1 gig. We're at 1 gig and our file is 2 gig, okay? Basically it's going to try to store the file. It's going to say, okay, store file in volume 1. Volume's going to say store 2 gig file in volume 1. Volume's going to say no space. And then the virtual volume is going to say, okay, FB has space. Okay, so it's going to say FB has space. Yes. Add another volume. And then it's gonna do this. So it's gonna add another volume with space to bucket. So basically the FB will have space, or we already know that the FB has space at that point. So we know that FB has space. Okay. Add another volume with space to the bucket. So basically the assumption is that the volume at this stage has enough space, so, or doesn't have enough space, the previous volume of the file bucket doesn't have enough space for some file, and we're basically saying, okay, we're going to add a new volume to the file bucket so that we can store a file there. So we're going to get the volume. So we're going to say vec auto-vec equals id vec pushback. Okay, and it's going to push back, and it's going to set. So because there's no pointer to it, we could do a shared pointer, but the issue with that is that then we do have a problem, right? Because if a volume gets removed mid-transaction to that volume, it's going to fail, right? And there's no reason to cancel the transaction because the volume gets removed, right, midway. The point is we had authorization to upload to that volume while the upload was happening. Now, once that upload is finished, we can then remove the volume. But then we have a problem, right? If we have a shared pointer to the vector, we're going to need some kind of mutex whenever an upload happens, whenever a host happens. We don't need that mutex because, first of all, it's going to take more memory. Second of all, the list of volumes is only important to lock when we need to persist it to the file, basically. And now, but the point might be, though, we might be adding file bucket volumes at the same time, right? Hypothetically, we could have a situation where the same file bucket is being uploaded to at the same time. Actually, this is already dealt with. If we have two uploads happening at the same time, the size will get statically incremented. And the static increment of the size would trigger an add file bucket volume for a bigger file. I think it would work. It'd be fine. So we don't need a lock. We don't need a shared pointer because at any point, the vectors get, oh, wait a minute. If we do get the vector and there's not enough space, and then during that time that's happening, someone else gets the vector and there's not enough space, they might both try to add a file bucket volume when only one of them needs to do that. But I don't think the mutex would solve either. They would both try to add, right? So that's fine. They would both add volumes. That might be an issue if one bucket is receiving many concurrent uploads at once. Let's say 64 in the span of a single second. In that case, we might have a problem because there's all this upload going on. They might try, each thread might try to add a new file bucket. Well, let's make a note of this. I don't think we're going to solve this today, but we're going to say note. This could be problematic not to have a mutex because many threads, many concurrent processes might try to add a volume all at once. What would be better is if there was a need for more space. The all requests for adding a new volume would halt and wait for the new volume to be assigned. Once it is assigned, we can return the volume to each waiting process. So the solution is basically when we add a file bucket volume, so if adding file bucket, already adding file bucket volume. If already adding file bucket volume, we'll just wait for that to finish. Return that new ID. So that way we know we already have a new volume. So both threads can basically get the same volume, new volume. They don't have to each get their own volume, right? Yeah, so in my structure, basically I have storage cluster node, right? Node is just the operations, the data, the data structure, etc. It is what parallelizes it. It's basically a singleton. It's for all intents and purposes only used. There's only one instance of the node, right? And then you have, and it has its own object pools, etc. for doing threading and stuff like that. Then you have the session. The session holds the unique pointer to the node, and it also, so it owns the node, and it also has all the networking stuff. So it's basically like the arbiter, the kind of manager of the node, in the sense that it receives all network requests and gives it to the node, and then sends it back to whatever node needed that response. So it separates the networking from the actual logic, and that way you could basically, if you didn't have a networking situation, if you didn't, you could use everything on the node without having a network connection. And so that's very powerful, I think. Basically, you would just need to format, maybe you want to do a TC, instead of doing TCP packets, you want to have different type of packets, and you could create your own different type of session that, parses those packets in that way. That's how I use that. So let's see. So add file bucket volume. Yeah. This is bad. Okay, so we have add file bucket volume. Load DB, we have load DB. We have destroy. We don't have commit storage volume. So add file bucket volume. Okay. So commit storage volume. I'm gonna cheat again. Okay, so commit storage volume. So we want to just add that there. I'm feeling lazy, so I'll just add it. Okay. Okay, so commit storage volume, we want that. I'm a bit OCD, not really. I know people say that as a joke and it shouldn't be a joke, but I'm a bit OCD. Okay. I like the order my header is in to match the order my implementation file is in. So, and it's not that way right now. So, okay, so get, and it's, I'm gonna rearrange this so I can fucking satisfy my OCD. Get file bucket volume IDs, set size is in line, commit storage volume, that's the one we need next. Actually, these should go up here. Thinking of taking a break soon. Okay, so, and then add file bucket volume and load DB, so the ordering is correct. Commit storage volume increments size by newly added volume size, adds to volume DB. We want to persist, and then we want and then we want to set vol DB. What is vol DB? vol db, fp vol db. No, that's not what it is. Vol db is in storage manager, isn't it? Yeah, volume here. So we're gonna do vol db set now when we commit storage volume, we're taking a I think I know what's going on here. Volumes set so commit storage volume commit size by newly added volume size and adds to volume db. So we have get size, set size, but we don't have get size. Interesting. Okay, so we're going to set size to get size. I'm going to do set size to get size plus volume size. This way we're interacting with the getter and the setter. If we need to do any mutex thing there, then it'll all be in that function. So there we go. There we have it. Set size is get size plus volume size. And then we want to return the new size, right? So we return... So we can just store this as const. I would say auto size, and we don't need to have it as const, but set size is size and return size. There we go. Commit storage volume. Okay. And load DB, so we have destroy here. I think I don't want this in line anymore. I'm going to move this. here. Because there's some complicated logic that comes with destroying the volumes. So I'm going to reconsider that. So let's see. So set size, destroy, void, volume, destroy. Okay, and we're just gonna have this here. Destroys the virtual volume. And yeah, this won't destroy backup volumes or replicated volumes for a very good reason. And yeah, so we have that there. And yeah. How long have we been streaming here? Oh, about 3 hours. Okay, that's not bad. Yeah, I heard a tummy rumble though, so probably pause the stream. Do a part 2. Let's see here. So we have that. Okay, what are we missing here? We have get storage volume, not present. Create storage volume, load storage volume we have. Remove storage volume is inline. So the only thing is get storage volume. That is the only thing that is not defined. So I'm going to add this and then compile. And then once I get that to compile, what the fuck did you just fucking say to me, bitch? Once we have that, I think I will be done. Storage volumes up here, and so okay. Question is, do we want to return the mutex? Right? Because if we're we're getting the storage volume, basically the volume, let's see, it has a copy constructor, but we don't really want, we don't really want that actually. Maybe any storage volume, it has a pointer, unique pointer. So when we get storage volume, we're getting a unique pointer, right? So we might actually have to return the tuple of the mutex and the value. So if we look at, I believe, file, we have this metaphor here. We get the lock and the master here. So we're going to look at that, and basically, master node here. It will get that. So we want to do that. We want to make a unique lock on the volume mutex, and then for the volume mutexes get on ID. And then once we get the once we have the mutex, the unique lock, we're basically going to return, we wanted to return a tuple of the lock and the volume itself. So that way, oh shit. When we get master, we're getting an instance of a singleton, meaning static memory. We can't do the same thing because here we're getting a unique pointer. So basically, when we get the storage volume, we need some way of reassigning the storage volume. Right? So I'd rather be able to visit the storage volume. And basically, within the scope of that visit, you would have it, but then you would not have it at some point, or at the end of the scope. Because otherwise, we're basically going to have to reassign the volume once we're done with it, right? So that's kind of confusing, right? So warning, Kali is responsible for reassigning volume to unique pointer again. So basically, moving back volume to manager. better way to do this? Perhaps we do a visit on the volume rather than move. So this way we don't really want to move around the instance. Yeah, we don't really want to do that because essentially we have like a problem with that, right? Because we don't really we don't want to have this problem of tying loose ends if an error case occurs, right? Because if at any point the operation fails, an exception's raised, whatever, if at any point that happens, we're screwed because then the unique pointer is still void. So I'd rather do a visit because if the visit fails, at least in the scope of the visitor, the unique pointer will get reassigned back to the map, back inside the map. And I think I want to do that metaphor more and more because otherwise we deal with this no pointer possibility. And I'd rather not have that be a possibility. So for now though, we'll just return this tuple and that will have to do until I think of a better way to do it. So do I include, yes, I include shared mutex. So yes. So then we would need to standard move on the volumes dot get ID. This will get the volume ID and return us the turn those to volume. So let's compile, see what happens. Alright, so we got an error. So we got ID up, oh, this isn't hashing, no viable constructor. Did we, oh, we don't have a default constructor. Yeah, we do. Can it infer template argument? Right. Okay. Okay. Get size should not return a value. Why is get size void? Because I'm an idiot. Okay. No matching constructor for initialization of volume storage volume manager. What the shit? Storage volume manager. I think it's because it expects a default size, right? Storage volume manager. Right, default volume size. So in this case, we want to say storage volume default volume size. I want to say that. The constructor as well. Volume mutex is get. No member name get in unordered map. need to do this stuff. That's right. Okay. That's right. So we need to auto mutex equals mailing mutex to seek find. I think I'll just do this later because I'm fairly close. I just need to swap out the get for find, and then we can recompile, see how that goes, and we're just basically going to keep doing this. We're going to keep doing this. We're going to keep going through these files, keep getting them to link with their C++ version, and then once we have the test linking correctly with the code, we'll be able to run the test and then one by one get everything working. And yeah, that's kind of the plan. So anyway, thanks for watching. I'll be back later, probably in like 40 minutes to an hour for part 2, and then we'll go on into the night. So thanks for watching. Hope you enjoy it, enjoy the programming, and yeah, I'll see you guys very soon. So thank you for watching. Again, I'll be back 40 minutes to an hour. And I'm on YouTube and Twitch. Please check out my GitHub for this project. And yeah, thanks for watching. See you guys.